today's assignment. Are there any questions over any of the other assignments so far? Any question over anything we've done so far? Okay. Now what we're looking at, and today is going to be the first day with solving, actually solving higher degree polynomial functions. Now with quadratics and ways we've learned to solve polynomial functions, well, the first one was factoring. If we can factor it, we can solve it. Because when we factor, we get multiple sets of parentheses being multiplied together to equal 0, multiple things being multiplied together to equal 0, so one of them has to be 0. The next way that we had was graphing. Luckily for us, we do have graphing calculators. We have technology that'll graph it for us, so we don't have to do it ourselves. The graphing calculator can do it. And when we graph, we're trying to see where the function crosses the x-axis. What value of x will make the function be 0? And both of these work for polynomials, so for our quadratics or any of the higher degree functions. And our third and fourth method, well, the third method was quadratic formula. And the fourth method is completing the square. Now, really, the third and fourth methods that we'll use here and we used before do work for a lot of higher degree polynomial functions. However, they do need to be set up in a certain way and behave a certain way. Because we could use the quadratic on fourth degree polynomial functions. It gets really complicated really quickly because we end up having to use something called U substitution, and then we're having to do it twice. So the values get very funky very quick. It's not very nice. I don't actually know because I haven't looked too deep into it trying to use U substitution and the quadratic formula at the same time. I don't think it works too well. Completing the square will sometimes work, but again, these are mainly going to be stuck with are mainly for quadratics. These are mainly going to be used for quadratics. And on a whole, when we start solving for any of these higher degree polynomial functions, if we can do factoring or graphing and get all the solutions, that's great. That's all we have to do. But if we're not able to find all of them, especially with graphing, we want to at least get it down to a quadratic, a degree 2. Because if it's a degree 2, we can use the quadratic formula, we can find the rest of them, and we're done. Because we've had multiple different ways to solve quadratics. Because hopefully, I think you got to the quadratic formula, you've covered most of the rest of them. Completing the square root method, all of those. Because if we can get it down to there, then it's easier to work with. That's the goal. Now, there are others where we can't do it that way, and those we have to start approximating or finding different ways to get to the values and using other tools to get there. And they're a little more complicated, a little bit harder to get to, but we won't go that in depth. Even at the college level, if they give you those, they will give you some hints at what the solutions are, especially for some if we know that one of the solutions is -4i. Again, complex conjugate. If -4i is a solution, 4i has to be a solution. So they'll give us some of those. Now, the first one we're looking at is this here. We want to solve 2x cubed minus 12x squared plus 18x equals 0. Well, the first thing we want to do in these first two here, we want to do it by factoring. So is there a greatest common factor between these three terms? 2 and x. And we can factor it out. If we factor 2x out of 2x cubed, we're left with x squared. Minus, if we factor 2x out of 12x squared, we're left with 6x. Plus, if we factor 2x out of 18x, we have 9. Because if we factor an x out of x, it's just 1, so we're really saying 9 times 1, which is just 9. Questions on this so far? Now at this point here, we could say 2 things multiplied together. We can technically say 3 things, because we do have the quadratic x squared minus 6x plus 9, yes? So it's being multiplied by x, and it's being multiplied by 2. Or we could say it's 2x times x squared minus 6x plus 9. We have two things. And anytime we have two or more things multiplied together to equal 0, one of them must be. So we could say that either 2x is equal to 0 or the x squared minus 6x plus 9 is equal to 0, yes? Well, let's solve the one on the left first. It's a little bit easier to work with, yes? There's two ways we could go about this. One of them is to do what? We can divide both sides by 2, yes? Telling us x is equal to 0, yes? Now, what property did we use to get to our two statements here? The zero product property, yes? Anytime we have two or more things multiplied together to equal 0, one of them must be 0. Well, if we look at this here, 2x is 2 times x, yes? I have two or more things multiplied together that give me, so one of them must be 0, yes? Is there any way I can change 2 into 0? Well, no, it's just a number, yes? So the only thing I can make 0 is, so x has to be. So really from here, we could have almost just jumped down and said x is 0, because we have 2 times x times our quadratic. Make sense? Now we do need to solve the other one, x squared minus 6x plus 9. So we could factor this still. So we would have two sets of parentheses with 3 spaces. Because the 3 and 5 would be the sum or difference of perfect cubes. So our signs, if the third term is positive, the signs are the same and match the sign of the middle term. So it is, so we'd have minus and minus. Now we look at the factors of the first and third term. Well, the factors of x squared are x and x. Factors of 9 that we want are 3 and 3. And if we check this here, we would get a middle term of 6x. Well, again, we have two things multiplied together to equal 0, so one of them must be 0. So we can say x minus 3 is, and x minus 3 is 0. So for the first one here, we can add 3 to both sides, saying x is equal to 3. For the other one, we can add 3 to both sides, saying x is equal to 3. So our solution is x is equal to 0, 3, and 3. And that's it. Any questions on any of this here? Greatest common factor. Yes. And we can factor that of all three terms. So if we factor 5x out of 5x cubed, we're left with minus. If we factor 5x out of negative 40x squared, 8x plus 5x factored out of 80x, which is going to be just 16. Now at this point here, we do have two or more things multiplied together to equal 0, so one of them must be. So we could say 5x is really just telling us what? X is equal to 0. We could say 5 times x is equal to 0. That's the same as saying x is equal to 0. And we also have that x squared minus 8x plus 16 is 0. Any questions on this so far? Let's graph this one. So if we pull up the graphing calculator, the first thing we want to do is hit y equals. So we want to hit y equals up at the very top, right below the screen. And across the top here, we'll type it in. So we can use this as x squared minus 8x plus 16. Any questions on this so far? Found it? Found the answers? Yeah, we'll show that here in a minute. So x, we can use this. And then we can say squared. And it's minus 8x plus. And then we can hit graph. And there's the graph. So we hit graph. So we have this here. Now, for the most part, the graph on this here is a little bit nice. One, because the screen's a little bit bigger than the one that y'all have. But what we can do also is if we hit second graph, if we do second graph, it'll pull up a table with our corresponding x and y values. And again, when we graph something, we're trying to see where it crosses the x-axis. We want to see what value of x will make the y value be. And if we look at this here, we have 4. When x is 4, y is 0. Now, one of the things we did cover with graphing, and we talked about, is even multiplicity. Because if the graph touches the x-axis but doesn't cross it, it has an even multiplicity. There's more than one 0 at that location. So really what it's telling us, x is 0 and 4 comma 4. Because if it doesn't cross it as an even number there, and so for this one here, it's going to be 2. Because all quadratics have 2 solutions. Now, if we factored this, we would have gotten x minus 4 times is equal to 0. We could have set both of these equal to 0. Added 4. X is equal to 4. And the same thing here. So we got the solutions of 0, 4, and 4. Questions on this here? So the function we started out with 5x cubed minus 40x squared plus 80x. So we start out with 5x to the third. What was it? Minus 40x squared plus. So we get values where x is, so what values of x makes y 0? Well, 0 and that works too. Questions on this here? So this here, find the zeros of f of x equals negative 2x to the fourth plus 16x squared minus 32. Then graph. Well, again, on the homework, I'm not going to ask you to graph. I'm not going to ask you to sketch the graphs of these here. Because one, they're kind of a little challenging to do, and most likely for you to sketch these graphs, you would use a graphing calculator or a graphing tool to graph it, and then you're just copying the graph down. There's no point in that. But what we can do is we can start off with the graph. So we could say negative 2x to the fourth plus x squared minus 32. And again with this here, just as a reminder, if the first number that we use is negative, we'll use the negative sign, not the minus sign, because it will throw a fit if it, that is, we put minus 2x to the fourth instead of negative 2x to the fourth. And then we can hit graph. So we do see it does intersect the x-axis at 2 points. We can say second graph. And those 2 points are negative 2 and 2. Questions on this here? Are we able to pull the graph up? No? If not, that's fine. Okay. Yeah, you're good. So our solutions for this here are x is equal to 2 and, now there's actually 2 more. They are also 2 and negative 2 because it does have a multiplicity of 2, so they repeat. Now, I'm going to show you this here that exactly that they do repeat, that these are 4 of the solutions. And the way we could do that is with synthetic division. And especially when we get to some of the other ones later in this part of the chapter and the next section, if graphing doesn't give us all the solutions, we're going to have to use synthetic division to find the rest, and get it down to a quadratic. So what I can do is pick positive 2 first. We'll have negative 2 for x to the fourth. 0, 16. So we'd have 0 for our x to the third and 0 for x. So we plug these in and we'll do synthetic division to see what we get. So we'll have negative 2. So 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. 2 times negative 4 is negative 8. 16 plus negative 8 is 8. 2 times 8 is 16. 0 plus 16 is, and 2 times 16 is 32, which gives us a remainder of 0. Okay. So yeah, so we know that 2 is a solution. Well, we got that from the graphing calculator. Now I can do it again, because as long as this gives me a remainder of 0, it means it's a solution. Even if it shows up more than one time, it'll still work out. Because if we do 2 times negative 2, we get negative 4. Negative 4 plus negative 4 is negative. 2 times negative 8 is negative 16. 8 plus negative 16 is negative 8. And 2 times negative 8 is negative 16, which gives us a 0. So we were able to show that 2 does work twice. Now, I would not copy this down because I'm going to go on and say I do it a third time. It doesn't have it 3 times, but if I tried it again, 2 times negative 2 would be negative 4. 8 plus negative 4 is negative 12. 2 times negative 12 is negative 24. Negative 8 plus negative 24 is negative 32. We don't have a remainder of 0, so it doesn't work a third time, but it does work twice. So you can erase all this here. But we knew what was a solution. Negative 2. So I can bring down the negative 2, and it's going to change the remainder. Negative 2 times negative 2 is 4. Negative 8 plus 4 is, negative 2 times negative 4 is 8, which does give us a remainder of 0. Now at this point here, because we started off with, this here was a degree, apparently it's in a scroll. This here was a degree 4, yes? If we do this once, it brings it down to a degree 3. Then we have a degree 2, which means our final statement here is a degree 1. We could do the synthetic division again. But at this point, if I put the variables back in, we have negative 2x minus 4 is equal to 0. Those are kind of nice to work because we had 4 to both sides, which tells us that negative 2x is equal to 4. So we show that the solutions are 2, 2, negative 2, and negative 2. We have 4 values. But that's it. And again, one of the biggest things with any of these here, and what we'll end up doing a lot with, is the graphing calculator is going to help us find, if not all the solutions, at least 2 less than the degree. The reason I say 2 less than the degree is because, well, if it's a degree 4 and we find 2, because 2 less than it's 2, we now have a quadratic. We can use the quadratic formula and plug it in and solve from there. So if we can get at least 2 less than the degree for the number of solutions, it's easy to solve from there. And that's really the goal. So if we look at this one here, x to the 4th minus 18x squared plus 81. We can graph it. X to the 4th minus 18x squared plus 81. So we can type it in there and hit graph. So it gives us these values here. And if we wanted to look at the table, it tells us that the solutions are -3 and 3. Now, because it didn't cross the x-axis, we can really say that we have 2 at each of those points. And there's 4. Because of the type of polynomial that we have, there are going to be 4 solutions for this here. We'll go more into that in 3.6 or 4.6, because the reason we get that and how we understand that is really tied into the fundamental theorem of algebra, which we'll cover then. But we won't cover that till Monday. Any other questions on this here? Feel pretty comfortable with these so far? Now we only have 2 left. We're going to do this one and the next one. Those are the last 2 we're going to do for today. We're going to pick the rest of this up tomorrow, and most likely we'll finish this up on Friday. Now, we can graph this here and get the solutions. I want to show you something a little bit different for this here. Because there is a way to solve this by factoring. Now, it might seem a little odd trying to factor this here. Because yes. It might seem a little weird trying to factor this, because up to this point, none of y'all have factored 1 with x to the 4th and x squared as the 2 variables. But it does look very similar to a quadratic. Now, something we can do with this here is something called U substitution. So when we substitute, we replace it, because y'all have done substitution with systems of equations where you substitute a variable in and solve for the other variable. Here, we're going to use it and say u is x squared. Now for our formula here, well, this part here, 4x to the 4th, I can think of it as 4x squared squared, because a power to a power multiplies. So that's the same as x to the 4th, minus 40x squared plus 36 is equal to 0. Now I can do that replacement with u. So we'd have 4. I replace the x squared with u, so I have u squared. Minus 40 times, well, we replaced x squared with u, plus 36 is equal to 0. Now, when we started with this here, 40x to the 4th minus 40x squared plus 36 did not look something like something we could factor. But by replacing x squared with u, we now have 4u squared minus 40u plus 36. That's a quadratic. We're used to factoring those. So we could work with that. So looking at this here, we could pull out a greatest common factor of what? Just 4. So if I factor that out, we have u squared minus 40, if I factor 4 out, is 10u plus 9 is equal to 0. And again, at this point, we could factor this. So we would have 2 sets of parentheses with 3 spaces. Now our signs, if we look at the third term, since it's positive, the signs are the same and match the sign of the middle term. So we would have minus and minus. The factors of u squared are going to be u and u. Now the factors of 9 that we want, because we have 1 and 9 or 3 and 3. 1 and 9. Because we already did one with 3 and 3 earlier, and we got a middle term of 6. And we could check this here to make sure. U times negative 9 is negative 9u. Negative 1 times u is negative u, which does give us a negative 10u, which is the middle term we wanted. Questions on this so far? Now we do have two things multiplied together to equal 0, so one of them must be 0. So we're saying either u minus 1 is 0 or u minus 9 is 0. But at the very beginning, before we really started this problem, what did we say u was? We said u to be x squared. We can plug it back in. So really what we have is that x squared minus 1 is equal to 0. Or we have that x squared minus 9 is 0. We have several different ways to solve these. As each one of these here, we can solve them by completing the square. We can solve them by the quadratic formula. Because there's no middle term, we can solve them by the square root method. Or we can solve them by graphing. Which way do y'all want to do? Square root method. Because there's no middle term, that means we can get the x squared term by itself and then square root both sides. So here we can add 1 to both sides, which will just tell us that x squared is equal to 1. And then we can square root. Square root of x squared is x is equal to plus or minus. Well, the square root of 1 is, well, there's 2 of our answers. We can do the same thing on the other side. We can add 9 to both sides, which will tell us that x squared is equal to 9. And again, at this point, we can square root both sides, which tells us x is equal to plus or minus 3. And that's it. Questions on this here? If I remember correctly, our equation was 4x to the 4th minus x squared plus 36. So this is the graph we would get. Now if I go second table, well, the solutions we found by solving it were negative 3, 3, negative 1, and 1, yes? Are all 4 of those listed? We could have done that way too. Now, if we factored the 4 out, because we've gone over this a few times, and I've told y'all, if we're solving, and there is a greatest common factor that's not a variable, we could divide it out. We can divide it out completely, yes? So if we look at this problem here, there is a greatest common factor of 4, yes? If I divided it out of each term, what we would have just x to the 4th to start with, minus 10x squared plus 9, yes? Now, I will say this will change almost all of the points on the graph, except for 4. There's 4 points that aren't going to change. And it's kind of hard to see it here, but the graphs do look different between the blue and red. If we look at the table, so the blue ones are our ones where we have the 4 included. The ones in red are the one where it's not. And if we look at, say, when x is negative 4, for the one that has 4, the y value is 420. If we divided that 4 out, we now have 105. But if we look at negative 3, the y value is 0. At -1, it's still 0. At 1 and 3, it's still 0. That's just a scalar. It's going to change everything except our solutions, which is nice because we can pull those out and make it easier to work with. It works with any of them. Because if we wanted to, and this is a little extreme, I can multiply the whole thing by 100. 100x to the 4th minus to 1,000 x squared plus 900. And we'll just look at the table. All the other numbers changed except for our 4 zeros. They're still the same. They stay the same. So that's kind of nice to know. But we can't do it with a variable. Because anytime we divide a variable out, we remove a solution from the equation. Any questions on this so far? This is the last one we'll look at today. But for us to be able to graph it, because I have a feeling that's what we kind of like doing because it works a lot better, a lot faster, we do need this equal to 0. With any of them, when we solve these higher degree polynomial functions, we need it equal to 0. So we need to subtract 14x cubed from both sides, which tells us that we have, okay, 2x to the 5th minus 14x cubed plus 24x equals 0. I'm going to list them over here so we have them. Does anybody have a guess at one of our zeros, what it's going to be? Is there a term listed there that does not have a variable besides our 0? No. So if I plug 0 into 2x to the 5th, it's going to be 0, yes? If I plug 0 into negative 14x cubed, which is 0. 0 into 24x, we get 0. So one value of x that'll make this whole thing 0 is indeed 0. And that's kind of a nice little, you could almost say cheat, because you just have to look at the function and see, is there a constant term? Is there a term without x? And if no, it means one of them has to be 0. And it holds up. It is true. Because if we go back to where we started this first one we looked at, this one here doesn't have a term without x, yes? What was one of our solutions? 0. Which is a blank screen here. Again, we had one without a constant term. One of our solutions was 0. So this one here, one of the solutions has to be 0. And what's interesting, the number of zeros that we have will be the same as the degree of the variable with the smallest exponent. So here, the smallest exponent is x to the 1st. So we will have 1 0. If it was squared, we would have 2 zeros at 0 because it will match up to it. Essentially, we're factoring that x out to the front, so it's just being multiplied. So it's kind of a nice thing to know, especially on a lot of standardized tests where they're making you try to do these quickly. Hey, there's no constant term. 0 has to be a solution. Makes it a little bit easier to work with. But what we can do is factor this. Not factor, we can graph it. So we have 2x to the 5th minus, what was our second term? Because I've lost. 14x squared plus 24x. Or I think it's 20 cubed. Well, let's see if I can get back to it. One more cubed graph. So we have this here, yes? It crosses how many times? Because we have 1 at the 0, And then it's kind of hard to see, but we do have 2 here and here. Now I can change the window a little bit and say -5 to 5. So 10 goes 5. 5 is 10. So I'm going to change the scale so we can see it a little bit. But we see at both of those it does cross twice. And it crosses in the center. So there's 5 places it crosses. What that tells us is that we should have 5 solutions. And based off the graph, we'll have 5. And if we look at the table, well, we found 3, yes? -2, 2, and 0. Oh, zoom 6. So 0, -2, and 2. Now what we'll do at this point is synthetic division. Because each time we do synthetic division, we decrease the degree by 1. So we have 3 solutions that we can do it with, which means I'll take it from a degree 5 to a degree 4, from a 4 to a 3, from a 3 to a 2. We can solve a quadratic. Now we just need to pick one of these values to do first. We can do it with 0. 0 is a nice number to do this with. So we'd have 2 for x to the 5th. Well, 0 for x to the 4th. -14 for x cubed. 0 for x squared. 24 for x, and then 0 because we don't have a constant term. We'll bring the 2 down. Well, 0 times 2 is 0. 0 plus 0 is 0. 0 times 0 is 0. -14 plus 0 is -14. 0 times -14 is 0. 0 plus 0 is 0. 0 times 0 is 0. Then we get 24, and 24 times 0 is, we get 0. Now, we could try this again with 0, but it's not going to work. Anytime it crosses the x-axis, it has what we called an odd multiplicity. So 1, 3, 5, 7, 9. But since we do have 5 places that it crosses, we'll have 5 solutions, and each one of these will only have 1. Now the next value we can try is 2. It's one of the other values that we had. 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. -14 plus 8 is -6. 2 times -6 is -12. 0 plus -12 is -12. And 2 times -12 is negative. And 24 plus -24 is 0. Now that comes down to the next one, the last one. The only other value we had was -2. -2 times -2 is -4. 4 plus -4 is -2 times 0 is -6 plus 0 is -6. -2 times -6 is 12, which gives us 0. So doing these 3 divisions brought it down to a quadratic of degree 2. So we can plug the variables back in. This here would be our remainder. 6 would be, -6 would be our term without x. 0 would be our term with x, and 2 would be our term with x squared. So really all we have left to solve is 2x squared minus 6. Now, we could try graphing it, but it's not going to help. Because we already graphed it to begin with, and those 2 zeros did not cross at nice points. But luckily, we don't have a middle term. So we can use the square root method. So I can add 6 to both sides, which will tell me that 2x squared is equal to 6. Then we can divide by 2, tell me x squared is equal to 3. Then we will square root both sides. Tell me x is equal to plus or minus square root of 3. Because we can't take the square root of 3. And the other values we had were what? 0, 2, and? Questions on this here? This is where we're stopping. Now, I did